I give you here some just indicators concerning the equipment. We spoke a lot about that. If you use efficient lamps, you see, for example, the old fluorescent lamps, the system efficacy was 85 to 95 lumen per watt, with a very limited dimming capacity, because dimming discharge lamps is complicated, and you need to have a very complicated electronic ballast systems with preheating and different other functions inside. That means the price of the ballast increase very rapidly. Compact fluorescent lamps, 50 to 76 lumen per watt. Some rare products can be dimmed, but their cost is enormous. Low wattage metal halide lamps like that one, 63 to 95, no dimming. And finally, white LED lamps, 100 to 200 lumen per watt, and very easy to dim. Well, you see here, when you look on that, clearly white LED lamps is the way to go. All the other technologies now, they are less interesting, energetically speaking. For the fixture side, you can use different technologies. You can use, for example, silver-coated reflectors, silver-coated reflectors on glass, not on plastic, because the quality of the plastic degrades with a year, especially when the plastic receives huge quantity of light, natural or artificial, and then you can go up to 80% of efficiency for that. Or when you have diffusing areas like that one, okay, in these fixtures there, in fact the LEDs, they are not behind, they are just around a plastic plate that plays the role of diffuser, and the light is coming in the diffuser and comes out like Lambertian. That means the same luminance to any direction. If you want to extract more light, the simplest way to do, well, the only way to do, is to use microprism diffusers in order to play with the extraction coefficient of the system, and then you can go up to 85%. But microprism or silver coated reflectors cost much more money than the standard systems that you can find everywhere. And finally, of course, concerning ballast, then you have to go to electronic ballast or drivers, and you can reduce up to 50% the harmonic distortion, but also you can reduce a lot the parasitic consumption. I remind you, for magnetic ballast, the parasitic consumption is around 20%. A good quality electronic ballast, the parasitic consumption is around 5 to 7%. Okay? This is a concrete example. This is a friend of mine from Romania gave me that, Dorin Beu. And you see here the place that the system has been installed, a small eco library in Romania. And in fact, they start with a good quality initial system. You see they had suspended fluorescent lamps, T8, 49 watts globally, and electronic ballast. And then for this system, the LENI was 29.8 kilowatt hours per square meter per year. And then they replace with recessed lighting fixtures using 36 watt LEDs. We pass from 49 to 36. Here they use silver coated reflectors, and the best option for the fixtures. And finally, the LENI passed for 29 to less than 10. You divide by 3 the consumption of the library, and if you calculate the global electrical consumption for the lighting, they won something like 20 kilowatt hours per square meter to illuminate for the same quantity of light. Okay? Of course, this is the more important. We don't have less, no more light. We have the same quantity of light, but just changing the system to more efficient parts, they want sufficient, a lot of energy. And here there is not any sensor or specific control. It's just switch on and off. Let's now look a little bit more closer this story, how we can make some automation inside the building in order to control the use time. This is the objective here. Well, there are different ways to use automation in order to achieve savings, energy savings. We start with standard system, not dimmable. That means you can just on and off. This is the case 0 is the reference. And then if just you use non-dimmable LEDs, you can achieve substantial energy. That happens in Romania. We want 20 kilowatt hours per year. The LEDs was not dimmable. We switch from old system to the new one. Now, if you add LED and dimming, you can have a higher savings. If you add LED and sensors, switch on and off sensors for the presence, or calculate the presence of daylight and adapt following how much daylight you have in the room. And finally, the best condition is to use LEDs coupled at that time with sensors and controls. Okay, and you can see here, it can go from 0% savings up to 75% savings when you are in that situation. This is excellent. You can, if you consume 1 megawatt hour in a part of your building, that means if you use the best option here, the best available technologies correctly, you pass from 1 megawatt hour to 250 kilowatt hours per year. Let's speak about the control systems. Well, in the past, controls was mainly used to turn on and off the light. That one. Day, night, that's all. More recently, the use of controls became more essential element for good lighting, because it allows to adapt the quantity of light at any place and at any moment. And studies shown that we can achieve, we can reduce the overall lighting energy consumption by up to 80% if we use the best available control systems. And to use control systems, I remind you that the only technology that is really accepting that is LEDs. All the other technologies, they are not really designed for controls. They are not designed for dimming. This is, again, I show you at the introduction, is the projections of DOE, and you see that clearly the gray part here, even in few years from now, the gray part is the energy savings thanks to the controls. Okay, let's go step by step. The first and easiest system is the manual on-off. Okay, manual on-off. You have the switch, you enter, you switch on, you go out, you switch off, but in mid-time, if the lighting conditions in the room change, maybe you will not have the time or the volunteer or I don't know what to switch off. Or you can go out, you go back home, you are tired, you forget to switch off the light, and if no one pass behind you to switch off the light, you will continue to illuminate for additional hours every day. Well, this is the worst case, and for that, for example, in Lenny, F0 equals 1 is the maximum value. There is a way to achieve a 5% savings, which is real an artifact, a small indicator here that the light switch on or off. Why they give you 5% credit for that? Because when the light is switched off, the small indicator here is lighted. That means you can see the button in the dark. And the idea is, if you have this habitude to see the button in dark space, when you will go out from your office, you click on the switch in order to see the small light coming out. Well, this is a pure sociological effect, and in fact you can win some energy just with this small indicator. That because they tell you you can add 5% savings, you can reduce F0 by 5% if you have this small switch here, which is just a small lamp in parallel with the switch inside the switch. And here is very easy to do. You just go to an electrical equipment provider, you buy a switch with a small indicator, and you replace your switch by yourself, and it works. Another way, this is a relatively old way, but still it is in use. You have it here. This is the example, is you can segment the space, and you can switch on and off the lamps following your needs. You see, you have many switches there, but a part is illuminating that part, another that one, another that one, and so on. And not only you save energy because this part of the theater is empty, no need to illuminate. We don't need to illuminate here because the contrast is not good and you don't see very well the slides. And it helps you to see better, but also saves energy. Okay? That means simply you have several switches, and when you have a lot of switches, you play for a few minutes till to find the right one to perform what you want. Same thing also, say here you have, for example, 3 ranges, and if you have windows here, you can say, okay, if I have enough daylight, I don't need to switch on that range, be that one also, but I will need always the last one because the daylight is declining very rapidly from the window till the other wall, unless if the premise is very small. Another way to save energy is to use timers that you have usually in the staircase in the buildings. You go out from your home, you push the button, the lamps come out, and after a few minutes, it depends how you set the timer, the light will stop. You want also to avoid standby power. For example, for your printers, your computers, you can put in your plug a programmable plug. You say, I want to be on the current arrive to what is plugged there from, say, 6 o'clock in the morning till to midnight, and then the plug will switch on and off automatically all the system. You have different kinds of timers. You have timers that they are just fixed. You say what is the duration. You have timers that you say is 0 or nothing from that time to that time. And you have also programmable timers that you can program all the system day by day, hour by hour, season by season, week by week, as you want. Yeah. Okay. It's nice. Up to show you up to now, all the and this kind of control switches, segmentation works standalone. How now you can connect all that stuff and be able to control all the stuff, all the network from a centralized point. This is the next step towards smart lighting. In fact, this is the legacy system. You have the lamp, any kind of lamp. You inject the power. You may have an analog timer or not. This is the only possibility here. And then the timer will send power to a legacy ferromagnetic ballast, and the ballast will power the lamp. The only thing that you can do here is to say to your timer, switch on and off, or maybe you can send also some analog signal passing through power line communication that say switch on and off. We use that mainly to save energy for water heaters at home when the electricity is less expensive in the night. The electrical company send a pulse in the electrical system, and the PLC knows that when this pulse is coming, then I will switch on the heater, and when another pulse is coming, I will cut the heater. Okay? You can do exactly the same thing by lighting. You can send some signals on and off, nothing else, because the bandwidth of power line communication is very low. You cannot do anything else. And also not only the bandwidth is low, but also depends strongly on the impedance of your cables. If you have very old cables, the impedance is very high, and then you distort the PLC signal, and the bandwidth is even lower. You cannot do anything else, just switch on and off. Then you have a more sophisticated system. Let's take the case number 2, that was the precursors or the pioneers in that domain. You may have a centralized control system equipped with a building management system that can communicate with different other elements, either with a power line protocols, with all the problems that I explained you here, or with RF links. For example, you can send an order, then you can have a controller here that is speaking a specific language, and will speak just after about DALI, about KNX, about different other protocols. And this controller gets the order, or someone can play with a controller and give his own order, send the orders to an electronic ballast that can understand the order, and I can say to ballast, switch on, or now if you are switched on, reduce by 10% the light, and things like that. And of course, I can add sensors that they can also send independently signal to the ballast and control the ballast or the driver. And the power, of course, is arriving here, not there. And then the ballast, the driver send the power to the lamp. You see that here the driver is independent of the lamp. We don't speak in here about plug and play lamps. We are speaking more about lamps, drivers, and usually the lamps and the drivers are inside the fixture. And then the more modern one, same thing, central system. Then the central system can communicate in two directions with the remaining part, can send and recover data. We'll speak about that. Then the sensors are here. The sensors send also data. The power is arriving to intelligent driver that takes all the orders. This can be done by fiber bus or IP protocols, or passing through Wi-Fi or Bluetooth. And then the ballast or the driver send the power to the lamp at the necessary level and collect status data from the system. For example, if one lamp is dead here or has a problem, then the driver can collect the data and send back the data to the centralized station in order to for example, say there is a problem with the system, we need maintenance. Or, even better, the intelligent driver can monitor in permanent way the system, and when you don't use correctly the system, you may have some failures, but always before a failure, you know that very well, there is some precursors. There are some signatures of the incoming failure. And if the driver detects such kind of signatures, either can tell to the central station, you need to do something in order to avoid a failure in the next days, or can take the decision to correct himself the problem. Okay, this is the self-healing. You see, all that we can do here was absolutely not possible there, and here it was much more difficult because you need always to be able to collect the data flow back. There is, we'll speak a little bit about sensors, what you can do with sensors. For example, this is presence sensors. You have different options. You can have a semi-automatic switch on and off. That means what? That means when I enter my room, I voluntarily switch on the light, and when I can go out, either the system can switch it off because it detects no more person is present in the room, or I can do it myself. Okay? And then you have the second mode, which is fully automatic. I enter, the system is switched on. I go out, the system switch off. And those two different operating modes, they are taken into account for the calculation of Lenny. I remind you that if the switch here has just a small lamp, the Lenny was 0.95. Same thing if you have a automatic on and dimming, is almost the same savings. But if you have a manual on and automatic off, you correct much more problems. People that they forgot to switch light off when they go back in the evening, and then you save up to 20% of energy. In fact, that to establish those factors here, we have used installed systems in different locations with a panel of users in different countries, and then we collect how much energy we save in average, and they decide what will be the coefficient here. Let's speak a little bit about that here, the presence detectors, and you will see that sometimes there are some problems. In fact, today you have two technologies of presence sensor drivers. One is using ultrasounds to detect moving objects, and the other is using passive infrared sensors in order to detect heat sources. And this allows you to switch on and off the light when you have a presence inside the room. There is the way that the two kind of sensors work. This is the motion sensors using ultrasounds. You see the sensor emit an ultrasonic signal in 25 to 40 hertz, and when you have something moving, you remember most probably the Doppler effect. When you have reflection of the wave, if the object is not moving, the wavelength stay the same. Now, if you are moving, then you compress the wave, and you have an apparent wavelength which is lower or bigger. It depends in what direction you go. And in fact, the sensors can measure this variation of wavelength of the ultrasonic wave, and following that can detect that is something moving around the sensor. This work with objects moving in a normal walking speed, which is, I remind you, normal walking speed is 4 or 5 kilometers an hour. Okay? They are not able to detect small movements. Okay? If you are sit in your room, let's take a very good example, more funny than that, and then we speak about the office. In many cases, we install such kind of systems in bathrooms. Okay, because people, they enter, out, etc. Okay, you enter the bathroom, you sit, and well, the system switch on, but once you are seated, the system doesn't detect any motion, and you have a timer, and at the end of the timer time, ploof, the lamp is switched off, but you are still there, and what you are doing, cuckoo, I'm here, and then ploof, the light is coming out again. Okay, this is funny. First of all, you have to be sure that the lamp that you have is an LED lamp accepting to be switched on and off very frequently. This is not the case of CFLs. But now take the same system in your office. Some very clever guys install that in a new part of the buildings in my laboratory. And what happened? You arrive, the system switch on, you sit in your office, you are writing, you are looking at your computer, and plaf, the system switch off, and you start again, say, cuckoo, I'm here, and then the system give you light again. Result, 6 months after, they had to change all the system in all the building, because it was not affordable. Okay. Second one, passive detection using infrared. I told you that each of us, we are 100-watt heat source. And when you enter a room with room temperature lower than the body temperature, then you emit infrared. And if you have a sensor, the sensor can understand that something is inside the room. And in fact, that we cut the space. There are several sensors in sectors, and the sensor can also understand that the source, the heating source, is moving. Okay? Fine. It works. It works in paper. You enter your room during winter time, you are hotter than the room, the lighting system detects you and switch on the light. Till you stay inside your room, that's fine, you are hotter, but if now you have a daylight coming from outside and hits your desk, the desk can be hotter than you. And the desk can be hotter than you if you leave the blinds open, even during the weekend, that you are not assumed to be in your office. And of course, in that case, the system will say, oops, someone is here, and will switch on and never off. Same thing, some people said we can put similar system in street lighting. That one or that one. This one works, okay, because you have moving cars and you switch on when you have cars. But it works also when you have cats or hear cows. It's something that is moving and they don't need light. If you put infrared in the city, what will happen? In winter time, they will detect the heat part, the engine of the cars, because you can say above a given temperature not detect humans. You detect the heat of the engine, that's fine. But if you are winter time with snow outside, not the case here, but you go to other countries, and you just get your car and your car is not hot enough, the system doesn't detect you. And in the summertime, or when you are in subtropics like here, it can detect that the asphalt is always hot, and then switch the light permanently. Well, you see, the use of such kind of sensors is not so straightforward. Sometimes you need to couple several with different options. You can use both, for example, and have some logic behind telling when both sensors give a positive information, then you switch on. If one sensor gives positive information and the other not, you have to decide what you have to do. This immediately complicates the system and start to request some artificial and some intelligence, not artificial. Another problem is where you have to position the sensors. And well, there are two options. Either you can put it in the roof, and then you have to know what is the area that the sensor can cover, and say if I put only one here, most probably will not understand what happened at the end of the room, how many sensors you have to put. Or I can put it on the wall, same thing, what is the area that the sensor can cover. That you have to remind, excuse me, is that I forgot to say that. Ultrasonic sensors can see behind objects. This is not the case of that. If you are behind your desk, the system masks your presence. This is the way that we can wire them. You have the lamp, okay, with connection to the earth for the metallic parts. We are here in class what system? Class 1, okay, electrically. And then you have the switch, and you add here the movement sensor, and you can just control the switch. And here is the protection fuse. Another way to save energy with sensors is to detect how much daylight you have available inside your room. Okay, you have the daylight coming from the sun, but also coming from the sky, and also coming by reflection from the ground or potential other constructions all around your place. And in fact, this daylight is decreasing almost exponentially with the distance from the window. If you have 1,000 lux here, most probably there, 5 meters later, you may have less than 10 lux of natural light, which is not enough. But globally, what you can do, you have three range of fixtures here. You say here I have enough daylight, I switch off that one. Here I need to complement the daylight with a little bit artificial light. I ask to this fixture to set at 50%, and here I don't have at all daylight. I ask the fixture to provide 100% of the power. And here, of course, you save energy, because this can be several ranks of fixtures, not only 1, 2, or 3. And globally, the idea is I want to maintain an illuminance level, which is usually for office 300 lux. We'll discuss about that this afternoon, how much light I need. And then it is clear that here you have an excess of natural light that you need to eliminate. But here you need to complement the blue parts with artificial light in order to keep your lighting level at 300 lux, for example, in all the surface. What is the benefit of daylight? Is improve the lighting conditions. Of course, daylight is free, but as you will see, just after, nothing is free in reality. Building using natural light offer better conditions for the workers. And in some countries like mine, the work legislation forbids to assign permanent workers to places that they don't have access to daylight. The disadvantage is problem of daylight is very random behavior. You may have clouds, you may have from one day to another the daylight is not the same. Depends on the position. You can have a glare. If the sun is just in your eyes here, you have problem dazzling. And you need also, as I explained at the beginning, further insulation of the wall in order to avoid overheating of the room. But if you are able to use daylight, you see by using different techniques, LENI for the FD natural light factor, you can go up to 20% savings if you use daylight control with sensors, for example, in schools and healthcare premises. How the daylight sensors work? In fact, you have a photoreceptor. Usually is a phototransistor, but can be also a photodiode or a photocell, but usually they are phototransistors. On the top, you have a diffuser to catch the light from all the direction, correct the cosinus theta that I explained you when the light is coming with an angle. And well, the light sensor, of course, measure all light. That means natural plus artificial. Has not the possibility to distinguish between the two kinds of light, and can be in different places, in the floor, on the wall, or maybe even in the table. Well, same thing, the sensors, you can fix a number, a level of available light, and when you are above the available, the necessary level, then the sensors can say, now I don't need this this fixture here, switch on and switch off, or can say how to adjust the light. They are mostly mounted on the ceiling, but the problem is this sensor in fact detects what? Detect the light that, if it is in the ceiling, detect the light reflected on the table going up in the direction of the sensor, and with an angle defined by the size of the sensor. This is exactly like our eye. That means the sensor in the roof detects the luminance, not the illuminance. And all the text, all the legislation, all the standards, they impose you an illuminance level. And the sensor doesn't measure the illuminance, measure the luminance. And this can be problematic because between the luminance and the illuminance is the reflection coefficient of the surface, and this surface don't have the same reflection coefficient as that one, or that one, or that one, because they are not the same materials, the same colors. That means it's impossible with a simple sensor like that know how much lux you have here. But if you put the sensor flip on your table, then it can measure the illuminance. But if you move it, or you go further, measure the illuminance here, not here. Well, once again, you see there are problems with this kind of sensors. And in any case, if we want to use, and we use them, we need to decide what is the position that this sensor has to be installed. There is I told you you have one here, and here you have several because you have windows. In fact, usually they told you if the high between the window opening here, this is the high of the window is h, then you have to put the sensor in a distance which is higher than half of the window size. It's a very simple thing, and of course you have to avoid always that the sensor can detect directly sunlight, because sunlight is very intense, but sunlight is dazzling. Sunlight, you don't like it, and most probably you will close the blinds. And also, you see the last part here, that a sufficient change in sensor response by changing the light quantity is not guaranteed if the maximum light in maximum high is not respected. That means not only you have to put it in a given distance from the window, but also the high, the position of the sensor has to be within some limits, otherwise is not able to detect rapid light variations and cannot adjust the light conditions as you expect. As I told you, everything has a cost, including daylight. Here is a building, and we have different kind of lighting inside. And if you say that the reference cost is daylight coming from the window, is 1, I don't know, is 1 rupee, 1 euro, 1 want, is 1, is relative. Why the daylight has a cost? Because you have to pay the window. Okay? Window costs much more than to have just brickles here. You open the window to get light, that means the additional price of the window is going to the light. And say that is 1. Then if you have just indirect light in the ceiling, and you collect back the additional light here, and you are exposed to enough daylight, then you multiply by 7 the cost of the system. If you have daylight wheel here, you collect light in the roof, you get it down in a place that you don't have access to daylight, the cost of that system is 16 times higher than that one. If you have just spots here with LEDs, this cost is similar to that one, 17 times higher. Here is the construction cost, here is the energy cost. If I go further, here I have just a roof light. I don't have to construct all the wheel. Even like that, the roof light cost me 2.3 times more than a simple window. And in that room here, when I don't have access to daylight from the roof light, because there are no windows, I pay much more electricity to light up my room, and my cost, the use cost, will be 23 times higher. And you can continue that one. And the idea is, okay, if I put here lamps that they are powered by photovoltaics. Yeah, okay, but the cost of the photovoltaic is very high. And finally, the light that you get here costs you 28 times higher than the light you get from just a simple window. This is also the reason why many legislation now, they push architects to use more and more windows, and they ask explicitly that workers, they have to have access to the daylight, either by windows or by openings or by atriums and any other thing that you can imagine. Okay, control and connected lighting. Do you want to make a pause, a break? Or, well, I have a little bit more. This is, if we continue, I have maybe for 20 minutes more. What do you prefer? Continue? Okay. Then, now we pass to the step above. We will need to have a control, automatic control of all that stuff, and connected lighting. Connected lighting, systems transforming the way that we interact with a system. Okay? And even we can have systems that don't need to interact in permanence with the end user. We can have two kind of connected lighting systems. We can have wire solutions passing through additional wires. I'm not speaking here about power line concept, or wireless radio solutions, which most probably is the future. Each of these technologies has its own characteristics with how to say, effect on how you will use the system and for what kind of application you want to use that system. Well, the wire technology, then you have beyond the power wires, you have additional wires that interconnect the different parts of the system, and those wires, they are used to transmit orders or maybe collect data back. Wireless is the same thing, unless that all the different controllers, drivers, and things like that, they can communicate by using radio frequency signals going from Wi-Fi to Bluetooth, an ocean, or any other LoRaWAN, what we can imagine. Wire technologies, and we'll speak about that a little bit more closer. You have different protocols. The oldest one, 0 to 10 volt. That means you have two wires that you can send a signal varying analog way from 0 to 10. If you are to 0, means lights are off. 1, lights at 100% of the power. If you are 9, means 90% of the power, things like that. Then you have more specialized protocols, DALI. This is the real standard for controlling lighting inside the buildings. DMX, which is also used for control lighting systems, especially for dynamic control, for scenic lighting, or even inside the aircrafts, they use DMX. And KNX is also a protocol that is used more and more inside the new buildings. I will explain you all that. And that is interesting that some protocols can collaborate between them. You can mix. If I take the radio technology, then it's the same thing, but here you have much more possibilities to transmit orders and collect data. Z-Wave, KNX, radio frequency, Zigbee, used a lot, an ocean, LoRaWAN. However, I remind you that LoRaWAN will disappear by 2029. It will be banned. And in any case, LoRaWAN has a big advantage, can cover very long distances, kilometers, but the bandwidth is very small. That means you can just send some information, switch on, off, past 50% of power and so on. Kazambi, this is something that becomes more and more important today, and also Bluetooth. This is the ancestor, the 0-10 volt dimming. Well, you have the LED driver, and then you have the 0-10 dimmer that adjusts associate the switch on and off. And this one, you have just a wall-mounted button that can be either something that you can play like a potentiometer, or you can switch for a given time, keep the switch on during a time, and then you have the value of the passing from 0 to something volts, and this allows to the driver to understand how much power has to send to the system. Well, this one start to be obsolescent. This one will disappear and is not really compatible with any of the new standards. DALI. DALI today is the most used protocol for lighting inside the buildings. DALI means Digital Addressable Lighting Interface. Is dedicated to lighting, cannot control anything else. It is open protocol, non-proprietary, that you can use it as you want. It offers digital light control quality with feedback. That means you send orders and you can know if the order has been executed. And is something that is standardized by IEC or NC. And you have the new versions of DALI, DALI 2, which is much more ambitious. And also here you have DALI Plus. Here you can add wireless communication plus IP addressing of the different devices. This one is exclusively wire. This one, DALI Plus, can be a part wire and a part RF. There is how DALI works. DALI is a bus. This is a very important thing. That means you have a DALI controller, and then you have here a DALI power supply, and all the devices, the ballast or the drivers that can understand DALI, they are in series, in bus configuration inside the premise, and that bus you can add sensors, presence sensors, light sensors, and you can have a DALI control screen that allows you to play with your system, and of course you can program that as you want. Well, the application control apply a given number of rules. You can find more information here. All the manuals, everything is open. Why? Because DALI has been created by an industry alliance that wants to create an open standard, and then they proposing products that they are compatible with DALI. Well, what does it allow to do? It allows to a precise, reproducible control of light output and standardized dimming curve. That means, you know, if you tell him, I want 50% light, it will calculate how less energy or has to send from the ballast in order to achieve 50% less light. 0 to 10, just say send 50% energy less to the lamp, but you are not sure that 50% less energy is equal to 50% less light. Okay? Here, you know that. It enables color temperature control. Today, with LEDs, we can have lamps passing from cool white to warm white because they mix a different kind of LEDs. And with DALI, not only we can control the dimming level, but we can control also the mix of the color temperatures and adjust the color temperatures. It ensures compatibility between ballast drivers and control manufacturers because they use all of them the same communication protocol. It provides flexibility for the designer and building manager. DALI 2 sensors can provide also information that can be feedback to the centralized station, and it collects luminar energy and diagnostics data. All the data can be collected and sent back to the centralized station in order to enhance maintenance. The first version of DALI was not able to do that. This is doable now with DALI 2. And it is very easy to connect for the installer. This is very important. You don't have hundreds of cables. You have 2 wires for the power, and or 3 if you take the earth, and 2 wires additional for DALI. And it is ready to communicate with Internet of Things and more complicated systems. There is how it works. You see, you have 3 cables, 3 lines for the power, including ground, and 2 DALI wires, the gray and the black, but there is no any polarity. That means you can connect the gray and the black as you want. You don't have to care about the polarity, and this is very nice because it's very easy to explain to installers that DALI, you have just to take the 2 wires and put it in the place that the ballast is marked DA. That's all. Instead to connect 3 cables, they connect 5. You can have it in bus. It works also in star, tree-like, or in series. It uses 1.5 millimeter square wires, classic standard wires. It's not polarity sensitive. The only thing is that you cannot go beyond 300 meters with brand new wires. In fact, DALI cannot accept voltage drop in that part beyond that 2 volts. That means if you know your DALI, if you know your wires, you can calculate what is the maximum distance in order to stay less than 2 volt drop. If you go above, the system doesn't work. Doesn't require any shielding for electromagnetic compatibility effects or interference because the rate is relatively low. You don't have interaction with other, okay. And in fact, it is powered at 16 volt DC, 235 milliamps. That means you have a parasitic power here. If you have 1, 2, 3, 4 DALI power supplies, in the Lenny calculation, you have to add this parasitic power here, 16 multiplied by 0.2. Is not a lot, but if you have many of those controllers, of course. Yeah, okay, that's all for DALI. The next one is DMX, DMX 512, if I use the official name. DMX stands for Digital Multiplexing. This one is very old. It exists since 1986 and has been established by the American Institute of Theater Technology. Why? Because you can control a huge number of devices. 512 stands here for 512 control channels. And of course, in theater, in scenical lighting, you need to play with color, with direction, with the motion of the light sources also, and all that stuff. And DMX can do it. Is most widely used communication in the domain of stage and architectural lighting. Also, when you light up the facades, changing colors, everything there is controlled by lighting. In hotels, in discos, showrooms. It's used also in cabin lighting in airlines and also passenger boats. Can be wire or RF. It is unidirectional. It doesn't support sensors. That means, for clear, if you want to have sensors, this is not the right protocol. And if you want to have feedback, this is not the right protocol either. How it works? Allows you to control up to 512 channels by assigning to each channel a value between 1 and 255. That means before starting implementing DMX, you need to have a correspondence table which channel number correspond to which device. The transmission can be done in serial way, you will see that. And each device receives 512 values and decide which one is for him. You can control that by using either a DMX console. You will see that in a radio studios or different areas, very similar with the sound mixer tables. Or you can also do it, of course, by using control software which is free in your computer and send all the information through USB, or you can use both together. Transmit only dimming values, level of light, tint for the color, speed, and also rotation, angle, or tilt for some projectors that they are moving. Okay? This is with a very high speed, going up to 250 kilovolts per second. Implementation, how you can implement DMX. Well, the standard provide a way to chain your devices, and you can chain up to 32 devices in a single line, and each device has 16 channels. Okay, that means you can say to the projector that is moving what color I want, what intensity I want, what position you have now, and what position we have 2 seconds later, what is the opening of the iris of the projector in order to change the size of light. You see, you can say to the same device, you have up to 16 degrees of liberty to tell the device what it will do with. It uses 120 volt shielded cable, but you can do it only with 2 twisted cable pairs and 5-pin connectors that you see here. And in practice, people using 3-pin connectors and 3 wires, shielded cables with impedance of 110 ohms. And as it is unidirectional, you have to define where is the termination. And you have to close the loop by using a termination cap of 120 ohms in order to be able to work with that. The range of the cable is 120 meters maximum if you are working in the RF frequency from 400 to 900 megahertz, and you go up to 700 meters if you are in 2.4 gigahertz. There is some examples of how to implement DALI. You have that one. You have here the power and the control, and then you have the green line is the DMX signal. Everything is connected in line with the cap at the end, and the red is the power line. This is the simple way to do it, but it's a bad idea, because if you have a disruption in the power line, then you lost all the projectors here, and if you have a disruption of the DALI line, you lost the control of all your system, because they are in series. Then you can do it in multi-line. You see here, you have the controller, the DALI signal, you send to a DMX signal, you send it in a DMX splitter that can then power different blocks of devices. And of course here, if you have something happen here, you will lose only the device that they are connected in that block. You don't lose the control of the remaining. Here is another possibility. You can have a multi-control with a console plus a PC to do different things. Many people want to play with the analog console here, but you can program some time variations with your PC, and then just you have to use a DMX merger that two signals and send to the splitter, and then you continue. And you can today use DMX with RF links in order to avoid to have mergers, splitters, and some additional wires. But then the principle is the same. Each line of devices is linked in series, and you need then also more than one caps. You have to close every line with a cap. KNX, this is a relatively new protocol, which is not an open one. It's a multi-system for home automation management protocol. Is doing the same thing what DALI is doing, but DALI is dedicated to lighting. KNX can control lights, can control ovens, can control blinds, can control doors. You can control everything. This is the difference. And you have two versions, the KNX standard, which is wired, or the KNX RF, which is exactly the same protocol, but use RF communications. This kind of protocols will find more in new buildings. It's very difficult to install in existing buildings. Okay, I leave that. Here is how KNX work. Same like DALI, you have a power line connecting, powering the different devices, and then you have a control line, the green one, that controls every device from lighting to heating to alarm to water controls and any other household appliance. This is very interesting because you can integrate everything in the same control system. Same like DALI, KNX is bus architecture. There is, look an example, I will show you that. You have this system, which is a lamp in your staircase. You switch on. You have a circuit button, and you put in the place a KNX control device, which is TOR, means in French two or nothing, everything or nothing, 0 or 1, with four inputs. And then you will add here in the mains KNX device power supply. We'll speak about that. With a KNX cable, you will add a presence sensors. The sensor will send the information here, and then you will add a second KNX cable here. And what happens now, when the sensors here detect someone, give the information here, and the KNX cable set the lamp on. When the sensors say no more is here, send the information to the KNX, and the KNX cable send the lamp the information to switch off. And that's all. Kazambi, and this is almost the last point that I want to show you. Kazambi is an advanced lighting control system based on Bluetooth energy technology, and it's communicating in 2.4 gigahertz. Here is no more wires. All the protocols I showed you before, they are wire, or in the new versions, they can be wire or RF. Okay, Kazambi is 100% wireless, and we found more and more 100% ready Kasabi products that we can add to our buildings. And here, in fact, you have your different lighting products everywhere. You have just an appliance, your mobile phone. You install a new light here with different capacities. You ask to your system to detect the presence of a new device. You say that device is this light, and now this light, if you can change color, I want that to change color every 5 minutes, or I want to switch on you and off at any moment, or I want this, I want that. You can program everything device by device in your phone. You send the sequence, and everything is executed. No consoles, no PCs, nothing. You can do everything just with connection. And also, it works in completely difference from the other device in a mesh structure. It's not a bus. That means if you lost the control of one device, everything else continue operating normally. And if your device is able, the driver is able to send information back to your system, then you can collect that information and feed with that different databases. And behind that, you can use, for example, artificial intelligence or I don't know what, to detect patterns. And if you detect patterns, you can control the system to a predictive way. And then you can go closer to a real smart systems. Kasabi supports different communication standards, is compatible with DALI, with an Ocean, and even is compatible with 010 volt. Can use PWM, power wave modulation, control power wave modulation drivers for making dimming. Can also make dimming with phase shift or control different relays. There is, you see, we are completely in a mesh configuration that I was telling before. The only thing is that the big difference between wire and RF systems like that, the wire systems are very difficult to hack. If you are not connected physically in the system, you cannot hack it. That one, if you find a failure inside the software layer, you can hack the system, and then you can have different negative effects. That's all, folks. Let's make a break till noon, and after that I will tell you other things. We will start discussing about how to light up, and we'll continue this this afternoon. Okay, because that part is may takes a little bit more time than just 1 hour. Okay. Well, questions? Yes. Oh yes, this is more closer to the problematics of daylight use. Yes, well, the reason that we use almost clear surface for the roof and the walls is in order to be able to reflect more light. Now, if you use mirrors, you will reflect more light. But I remind you that mirror, they keep the image. That can be very distracting for someone. If you are in your desk and you have around you mirrors, you may stay there and look yourself and thinking about something else, not working. But even if in that case the sun is coming from the window behind you, and it's very nice to light up your office, your desk. The sun will be reflected in the mirror, and then you can get it in your eyes. That means you will close the blinds, even if you are not looking the blinds directly, and then you will reduce the sunlight. Well, mirrors for working places is not a good idea. Now for discos or things like that in the evening, if you want to create other kind of effects, yes. But mirror walls, they are not good options. The good option is to have very well reflecting surfaces, clear surfaces, but then you need to maintain them. In an office, if you have white walls, it's okay. If you put that in a factory, within a few months, it will be black. Okay. But for example, you can use ceramic plates, white ceramic plates, in order to collect light, and that is something that is done since beginning of 20th century in the Paris metro, which is one of the older metros in worldwide. We have that we call the metro ceramics. You have white plates with a specific shape that has been calculated to reflect more light in the platforms and avoid to have a lot of electrical light to deploy inside the station. But yes, you are right. But not mirrors. Something reflecting is okay. Yes. Other question? How? The shape. Oh, the shape of the shape of the beam. It is done thanks to the optics inside the fixture. Now you can add mechanical parts inside the fixture that you can control with something else. Normally we don't like to have mechanical parts in lighting because they are very sensitive and they need a lot of maintenance. But when you go to a theater, you know, you have these projectors that are usually on the floor, which is black and can turn to all directions, and then you can change also the size of the beam. You have mechanic parts inside. I call this kind of projector Robocops. They can move to all directions, but you can program that, and that you can do it only with DMX. But the shape of the optics is the optics part of the fixture. Okay. Okay. Let's recombine at noon.